kindly remind me that we have a keynote after this final presentation from Steven Feldman. Yes, I think I was talking with him on the main auditory.
So, may I? Okay.
So, prego.
Thank you. Welcome you all, and let me introduce myself. I'm Tomas Kavan from Melon Technologies, and today I would like to talk about advanced system for rendering text in 3D maps. I'm going to skip those those two slides
Thank
at
you.
all because you already heard them twice. So just give me a second. I have a little glitch here. Yeah. So now it's fine. So on the beginning, let me ask one rhetorical question. Why Latin glyphs are not enough. Latin glyphs dominated labels in digital cartography for a very long time, but recently we are seeing gradual changes towards support of non-Latin glyphs. It's a natural thing when we take in account that more than half of the world doesn't use writing system based on Latin at all. So let me take you on the small virtual trip around the globe. As you can see, more like you cannot see, I say. It doesn't matter. Just believe me that there are only Latin glyphs in labels in Portugal. We can go over to Europe, and you will see mostly Latin glyph at all. If we go a little side on the America, there are Latin glyphs either. But there are some minor writing system in suppressed cultures which are not displayed, and it's a little shame. And of course, once we are turned the globe over to Asia, that's where the hell started, because as you can see, those glyphs are almost all of the glyphs are not Latin. Take a closer look. Okay, I'm going to skip it because it's kind of pointless. Yeah. So let me summary this topic. There is more than 10,000 of languages around the world, and more than 3,900 of them developed its own writing system. So not all of them are alphabetic. Where glyph represents one vowel or consonant. But there are logographic systems where glyphs represent words or morphemes. And of course, there are many other types. Different writing systems are not the only problem we are facing. Most of a writing system has a set of rules how to compose and substitute some glyphs with others. The substitution rules itself, it's a concept which is very foreign for us as Latin speakers and writers. And finally, we cannot omit the directionality. There is not only left to right and right to left, but there are at least 5 known directions in writing system. For example, Chinese writing from top to bottom and then from right to left. And what is the real deal is to properly mix together different writing system directions in one text. Okay, let's take a look how we are dealing with writing system in computers. Just a very high-level overview. In computer systems, we have a so-called computer fonts, and it's basically containers for all informations which needs to be held together for a rendering system to be able to display some text. As you can see here, for example, there is a open type font container which contains vector descriptions of all glyphs, the set of rules, mapping tables, and other supporting modules to render the text on the screen. The important thing about computer font is that there is a very limited number of glyphs which you can store in one container. Each operating system has its own text rendering subsystem, and we just take a string as input and use informations in the font container to render text on screen. And it's usually very advanced and very proper, but it's not supporting rendering of text in 3D systems like WebGL. So we can use it. There are libraries to render fonts in WebGL and OpenGL applications, but they are too big. And so we won't use them because in streaming the size of code matters. So there is one important thing that user may not have all fonts we need to render on his computer. So we need to bring our fonts at all. Let me summary those problems. We have a 3,900 writing systems, hundred-thousands of glyphs, and countless rules. And on the other hand, we have a limited font files, low internet bandwidth, and we cannot use system rendering subsystem. And we want to deal with this. We already did that. Our goal was to implement a system which is capable of displaying geographical labels with non-lacking glyphs in 3D maps with custom fonts. So we needed to meet some challenges. First was wrapping glyphs and rules together. The second was streaming those wrapped data with as less data as possible to user. The third is cascading multiple fonts together. And the last one is rendering various sizes, colors, and styles. Because my pre-speaker made a great deal with explaining what VTS is, so let me tell you that the rendering system is part of front-end JavaScript rendering library, and let's focus on those challenges. Challenge 1: wrapping. VTS has its own font container format called VTS font file, and it gains advantage from the true types font modular architecture. So we simply replaced the glyphs with textures, which is suitable for rendering using WebGL. Something like that. VTS contains a tool for this task, and you can take any open type or true type font as you want, and just convert it to VTS font file. The second challenge was streaming. Once you have a font which is suitable for rendering using a WebGL, you need to have a facility how to stream as less data as possible to client, and only when those data are needed. So we divided the textured glyphs in planes and separate them in different files. Those files are loaded on demand. So it's saving time on the beginning and the amount of transferred data. And of course, to reduce amount of transferred data even more, the font generator tries to utilize as much of space as in plane as possible. The third challenge was a cascading, and it helps us. We may want to render one label with multiple fonts. For example, we have Latin and Myanmar glyphs in one label, and we want to render Latin glyph as Arial in italic, but italic doesn't make a sense for Myanmar fonts. So we need to create a cascade of fonts, as you may know from cascade style sheets. Then when the Myanmar character is being rendered, say Unicode 1029, first the rendering system looks into Arial italic font, and the glyph is not found. So it continues through the cascade to the Arial alphabetic, where the Myanmar character is found, and it's rendered on the screen. On the other hand, when we have a Latin char on input, let's say it's Unicode 41, which is big A, the glyph is found in the first font, which is Arial italic, and it's displayed. The result we can achieve may look something like this. As you can see, the Myanmar writing system is not italic, but the Latin is. So the cascading help us to avoid missing glyphs. You can cascade as much font as you want, and as many font as you want, and only when any of those font doesn't contain the desired character, the missing glyph is displayed. So the last challenge we have faced was rendering. Rendering textured data, it's not so good for for fonts, because you want to change the size and add some effects like shadows or strokes. So we decide to code the glyphs in textures as signed distance fields. And this approach allows us to add effects like stroke, shadow, fill, and it's very good approach to change the size of rasterized data, as you can see on this picture. Now we have addressed all challenges, and I want to show you how the text render system is integrated into VTS JavaScript library. To affect visual style of rendered vector data, VTS have a GeoLayer style sheet. It's a CSS-like format, but coded as a JSON file, and it contains properties modifying appearance and of rendering texts. There are very basic steps what we can do with the fonts in GeoLayer styles. On the first row, custom font is defined, so when you get the result from the font generator and put it somewhere on the web server, you just need to address it here. On the second row is place where the font cascade is defined. So in this particular cascade, as on the first place is a font which I called my font. Then there is some other two fonts which is give us the complete cascade of almost all glyphs we may need. And the third arrow pointing to line where we're assigning the font cascade to a specific vector feature. In this case, country text labels. And the result may look like this. The my font was the serif one, so almost all country labels are in serif font, but you can see the exceptions. For example, here in Greece, the my font doesn't contain Greece glyphs, so it's still the other sans serif font. Okay, so let me show you a short live demo. I have a map here, and I'm going to change. You didn't see it, huh? Just give me a second. Now. Unfortunately, the browser doesn't go well with this screen resolution, so so there won't be any live demo. Okay, so thank you. That's all from me for now, and I want to invite you to other talks about VTS, and mostly about technology. And that's all. Thank you.
So, no one? So, if there's no more questions, I'm going to close the floor and advise you to go to the final presentation on the major auditory. So, thank you very much for coming for this 3D and Mello company panel, and see you soon.